Welcome to my high-performance Java persistence video course. Today we are going to talk about the lost update anomaly. On the screen, you can see an excerpt of my book, High-Performance Java Persistence. The lost update anomaly happens when a user overwrites a record without acknowledging that the row was changed since the last time it was read. For instance, in this diagram, Alice reads the post record. In between, Bob changes the post title from transactions to acid. Then Alice's thread resumes and she updates the record without knowing that Bob has changed it since she first read this record, and then Alice commits. We call this anomaly a lost update because, from the perspective of Alice, Bob's update has never existed. This phenomena can happen in read-committed isolation level, or even in MySQL repeatable read. To prevent it, you either have to acquire a shared lock on the row that you read, or use optimistic locking. The previous example assumed a single physical database transaction. However, the lost update can also happen in application-level logical transactions. In this example, Alice reads a product from the database and the product is displayed in the UI. Then, a batch process comes in and updates the product quantity to 0, as depicted in the warehouse. Alice does not know that the product quantity has changed, so she assumes that there are enough products to be bought, as depicted by the quantity displayed in the UI. If she simply decrements the product quantity and saves the product quantity will be 4. However, that means we just overwritten the batch process update. Not only that we broke serializability, but we now display a quantity value that's no longer consistent with the value coming from the warehouse, which was set by the batch process. To fix this application-level lost update anomaly, we can no longer rely on database isolation levels, like serializability, because the logical transaction spans on multiple database transactions. However, application-level transaction anomalies require application-level concurrency control mechanism, like optimistic locking. There are two things we need to do to prevent this phenomenon. First, we need to retain the previous product snapshot in between the read and the write physical transactions. Second, the product must use a version column that's always incremented based on the previous read version value. So when the batch process updates the product, the version is changed from 1 to 2. When Alice tries to update the product quantity, she will use the previous version value as a predicate in the update where clause. Because the version has changed, no record will be updated and the return update count is going to be 0. This will trigger an optimistic locking exception in JPA and Hibernate. That's why optimistic locking is the best way to deal with the lost update anomaly.